Hi and welcome to another video tutorial. In this video, we are going to explore one of the most important and basic mathematical concepts we need to know in order to excel in physics. So we are going to talk about the concept of trigonometry. Trigonometry is sometimes called trig. Let's begin by asking ourselves the question, what is trigonometry or what is trig? Trigonometry is a branch of mathematics which deals with the study of right-angled triangles and the relationships between their sides and angles. This means that when we are talking about trigonometry, we are actually talking about right-angled triangles. So let's consider this right-angled triangle. Let us call it triangle ABC. Now let us note where the angle theta is. In this diagram, it is found at C. It can also be found at A in another diagram, but not at B. It is only the right angle that can be located at B because the line AB and BC meet at right angle. Where the angle theta is located is very important because it tells us which side of the triangle is the opposite. As we can see, the triangle has three sides. There is a special name we give to each side of the triangle. And so let us identify the three sides of the triangle. First of all, we have AC, which is the longest side of the triangle. It is called the hypotenuse. Also, we have AB, which is opposite to the angle theta and therefore called the opposite. Then the third side, BC, is called the adjacent. We can relate the sides of the triangle to each other. These relations are called the trig ratios. So there are three important trig ratios we can get from any right-angled triangle. The first ratio is the ratio of the opposite to the hypotenuse. This is called the sine ratio. So sine is a ratio of the opposite to the hypotenuse. Now we can find the sine of the angle, and the sine of the angle, that is the sine theta, is equal to opposite over hypotenuse. From the diagram we are using, we can say that sine theta is equal to AB divided by AC. In case we want to find the angle theta, we have to find the sine inverse of the ratio opposite to hypotenuse. And this is how we write it. Theta is equal to the sine inverse of AB divided by AC. Now, let's talk about the second trig ratio. It is called the cosine ratio. And the cosine is a ratio of the adjacent to the hypotenuse. And so we can write that the cosine of theta, which we write as cos theta, is equal to the adjacent divided by the hypotenuse. And using the sides of the triangle from the diagram, we can say that cos theta is equal to BC divided by AC. We can find the value of the angle theta using cosine, and in this case the theta is going to be the cos inverse of BC divided by AC. The third and final trig ratio is what we call the tangent. So the tangent is the ratio of the opposite to the adjacent. We can write that tan theta is equal to opposite over adjacent. So we can further write that tan theta is equal to AB divided by BC. If you want to find the value of the angle, you can find the tan inverse of the ratio, which we are going to get theta is equal to tan inverse of AB divided by BC. We have to note that whether we use sine or cos or tan, the value of the angle is going to be the same. Now there is a simple way we can use to remember the ratios. Sine is usually said to be SOH, which is spelled SOH. And so we say that sine is a ratio of the opposites to the hypotenuse. Also, cosine is said to be CAH, which is CAH. And so cosine is the ratio of the adjacent to the hypotenuse. And then tangent is said to be TOA. And so it is the ratio of the opposites to the adjacent. And so the three can simply be referred to as SOH-CAH-TOA. And this is very prominent in using trigonometry. Now there is another mathematical concept which is usually used in combination with trigonometry. And this mathematical concept is called the Pythagoras Theorem. The Pythagoras Theorem also deals with right angle triangles, but it doesn't deal with any angle. It only deals with the three sides of the triangle. And so Pythagoras Theorem is able to relate the three sides of the triangle perfectly. From Pythagoras Theorem, the square of the hypotenuse is equal to the sum of the square of the opposites and the adjacent. And so from the diagram we are using, we can write that AC squared is equal to BC squared plus AB squared. And in case we want to find the length AC, it means we have to take square roots on both sides. And by taking square roots on both sides, we are going to get the side AC is equal to the square root of BC squared plus AB squared. And this is a very important relationship we will need together with the trig ratios to solve a lot of problems. Having explored what trigonometry is, now let's solve some examples. Our first question is to find the value of theta, cos theta, and tan theta from the right angle triangle given below. So we can see from the right angle triangle given below that we have been given the hypotenuse, which is 5, and the opposites, which is 4, and the angle. And so we can first of all find the value of theta. If you want to find the value of theta, you can use any two of the given sides of the right angle. So in this case, we are going to use the opposites and we are going to use the hypotenuse. And so we are going to use the ratio of sine theta, because sine theta is the ratio of the opposite to the hypotenuse. So we can write that sine theta is equal to 4/5. Now if you want to find theta, which is the angle, we have to take the inverse of the sine of 4/5. To find the value of theta, we have sine inverse of 4 divided by 5. And by working this on our calculator, we are going to get 53 degrees. So the value of the angle theta is 53 degrees. We are also to find cos theta. In order to find cos theta, we need to find the adjacent, because cos theta is a ratio of the adjacent to the hypotenuse. And to do this, we have to use Pythagoras theorem. So let's name the adjacent A. Using Pythagoras theorem, we are going to have 5 squared is equal to 4 squared plus A squared. Now 5 squared is 25, and this will be equal to 16 plus A squared. So now let's group like things. We are going to have 25 minus 16 is equal to A squared. 25 minus 16 is 9 is equal to A squared. To find A, we have to find the square root of both sides. So the square root of 9 will be equal to the square root of A squared. The square root of 9 is 3, and the square root of A squared is 8, which means that the adjacent is 3. So now we can write that the cos theta, which is equal to the ratio of the adjacent to the hypotenuse, will give us 3 divided by 5. Now the third one is for us to find tan theta. tan theta is a ratio of the opposite to the adjacent. And so we can simply write that tan theta is equal to 4 divided by 3. There is another way we can find the value of tan theta if we have cos theta and sin theta. And that is, tan theta is a ratio of sin theta to cos theta. And so let's explore. We are going to have 4 divided by 5 divided by 3 divided by 5. And by computing this, we are going to get 4 divided by 5 multiplied by the inverse of 3 divided by 5, which is 5 divided by 3. And when we compute this, we are going to get 4 divided by 3, just as we had previously. Now let's take our second question. Our second question reads, find the value of yz and xy in the diagram given. This time we have been given an angle located at x, which is 67.4 degrees. So let us find the side yz. We know that the side yz is the opposite, and we have been given the hypotenuse to be 13. So we can use sine to find the length yz. So we can say that sine 67.4 is equal to the side yz divided by the side 13. Remember that sine theta is a ratio of the opposites, which in this case is our yz to the hypotenuse, which is the 13. And so we can multiply 13 by the sine 67.4 degrees. And this will give us 13 sine 67.4 degrees equal to yz. When we compute this using our calculators, we are going to get 12. Also, let's find the side xy. To find the side xy, we can use any of the 3 sides given, but the most convenient and the most safe method is to use the figure we have already been given in the question. Perhaps the one that we just solved is wrong. So it means we are using 13, which is the hypotenuse, and the side xy, which is the adjacent. So it means we are going to use the cosine ratio. So we can write that cos 67.4 degrees is equal to the side xy divided by 13, because the cosine is a ratio of the adjacent, which in this case is the xy divided by the hypotenuse, which is 13. So once again, we can multiply 13 by cos 67.4 degrees. So we are going to get 13 cos 67.4 degrees, and this will give us xy. When we compute 13 cos 67.4 degrees on our calculators, we are going to get 5. So the side xy is 5. Now we want to use Pythagoras Theorem to prove it and see. In other words, for finding the side xy, we can also use Pythagoras Theorem to do that. So using Pythagoras Theorem, we know that the side xz, which is the hypotenuse, is 13. We found the side yz to be 12, which is the opposite. We are supposed to find the side xy, which is the adjacent. So we can write that 13 squared is equal to 12 squared plus xy squared. 13 squared is 169. It will be equal to 144 plus xy squared. Now let's group like terms. We are going to have 169 minus 144, which is equal to xy squared. When we subtract, we are going to get 25. And when we take square root on both sides, we are going to have 5 is equal to xy. And it's the same as the answer we had earlier on. And this is what makes physics and mathematics beautiful. Whether we use trigonometry or whether we use Pythagoras Theorem, we always arrive at the same answers. I am sure you have found this tutorial very useful. We therefore encourage you to like, share, and most importantly, subscribe to our channel. Thank you.